The paper that I present is a systematic review of service level management in the cloud, published in ACM Computing Survey 2016. My name is Yongrae and I'm currently a PhD candidate of Pohang University of Science and Technology. Big companies like Amazon, Google, and Microsoft, they are all competing with each other to produce better cloud services. As a result, cloud computing has a huge impact on other computing areas such as fog computing, edge computing, service computing, IoT, container, software-defined network, big data, machine learning, and blockchain. Actually, a recent paper from the same journal describes cloud's main impact areas like these. Motivation is quite clear. Cloud is pretty mature. However, SLA is yet to mature because critical applications cannot still be reliably deployed in clouds, which is mainly due to the fact that the SLA is defined in an ad hoc manner or at best standardized only for limited organization or application domain. So the paper systematically surveys the landscape of SLA-based cloud research. I'll explain some backgrounds in the following few slides. Let's take a look at the service level agreement. SLA was traditionally a business concept. The SLA specifies contractual financial agreements between parties who engage in the business activities. But the computational SLA is used in cloud computing to specify how to measure service metrics in the computer system. SLI, SLO, and SLA. Service level indicator or SLI represents a key performance metric. SLI is also called SLA parameters. Service level objective or SLO represents a condition on a SLI. And service level agreement or SLA is simply a set of SLOs, as in the below table. Representative examples of SLA can be from AWS. You can check out those SLAs such as AWS Customer Engagement Agreement, Amazon Computer Service Level Agreement. XS means anything as a service. There are many XS models as in the figure. But the XS models that is considered in this paper is this table. The paper considers IaaS, infrastructure as a service, and SaaS, software as a service, and PaaS, platform as a service, DaaS, data as a service, NAS, network as a service, SaaS, storage as a service, and CF, cloud federation or federated cloud services. This figure is one example to help understand an architecture of cloud federation or intercloud. There are multiple cloud service providers and they are combined to provide a cloud service. Autonomic computing and self-adaptive system. Autonomic computing is to automate a task of computer system self-activities by making the computer systems as self-regulating and intelligent. So this leads to decreased human involvement. This system architecture is inspired from human organic body and firstly proposed by IBM at 2004. You can see that the main characteristics of system include self-configuration, self-integration, and self-optimization, and self-healing, and self-protection. Most representative example of the autonomic computing is a MAPK architecture, which means monitor, analyze, plan, and execute with knowledge. Knowledge here means that the system can get a feedback from an external environment or internally. Typical MAPK architecture consists of managing subsystem and managed subsystem. Managing subsystem literally manages managed subsystem, which gathers sensor data from an external environment. Then, managing system analyzes gathered sensor data and make a plan based on the analysis. And then managed subsystem executes the plan. The reason why of introducing autonomic computing is because cloud computing can be architected as an autonomic computing as well as self-adaptive system. And key autonomic properties of a cloud includes on-demand elasticity, dynamic resource management, scheduling, and etc. And this is the SLA management life cycle. First step is SLA negotiation, in which it defines terms and both customers and providers are agreed on proposed service levels. And next, SLA establishment is a valuation of the SLA, which means that the service provider actually fulfills SLA. After that, an important SLA monitoring that collects data as well as analysis of the data. After the analysis, violation can be detected, and if detected, resolve action can be taken. Also, SLA can be reported so that the customer can decide whether or not to terminate service or not. So autonomy cloud can be reliably running with SLA management lifecycle. Before proceeding, it is worth noting that what a systematic review is. Systematic literature review guideline used in this paper provides an evidence-based literature search. In the systematic review, the survey uses explicit and reproducible method. For example, it should specify search protocol explicitly, and the survey should be fair, rigorous, open. An original paper claims that you should be empirical and collect evidences from practical experiences for decision making. And this is the typical process of systematic review process, and used indexing services in this survey, and search terms are cloud service, end condition, SLA, end condition, resource allocation. And the results are 3,592 papers, and among them, authors studied 106 papers. And authors also devised a survey classification framework. So they applied their framework to their studied papers. In this framework, they identified general properties like access model, used SLA template, architecture type, and application domain. In the SLA parameter, they identify mostly studied and least studied and average studied parameters. And resource allocation techniques are also identified by application domains and access models. Lastly, software architecture type is also identified as well, whether it is autonomic or not. The core research questions in this survey has three folds. First, what are the SLA parameters of interest to cloud stakeholders? Second, what are these techniques used for adaptive SLA-based resource allocation? Third, what are the dominant architectural styles for realizing cloud solutions? And the answer is like that. Answers to the first question, performance, memory, and CPU cycle are the most studied parameters. And answers to the second question, heuristics, policies, and optimization are the most commonly used techniques. Last answer is that MAPK and its variant are the predominant or self-adaptive architecture style. Actually, this is the result of this survey paper, and this is the conclusion of this paper. And the other followings are supplementary for these answers. There are actually standard SLA templates such as a web service level agreement or WSLA, language specification, and web service agreement, but nobody used this standard template in the academic world. The researchers used their own ad hoc template for their SLAs. Following few slides are for explaining the survey result, and I'm not going into details of this survey. This survey's result shows that each access layer considers different SLA parameters. And this is the SLA parameters by measurement, and authors build a pie chart of SLA parameter distribution. As you can see, performance consideration of SLA is the most interested parameter in the research. And these results show that the average number of SLA parameters considered in each paper is almost 1. Let me skip this, this survey result of SLA-based resource allocation techniques and software architecture styles. But this result is quite interesting because trade-off analysis between completing SLA parameters can be essential for complex SLA-based cloud system management. Authors identified several trade-off analysis in the paper. 20% of the reviewed papers provided trade-off analysis between completing SLA parameters. And there are at most 3 SLA parameters in the trade-off analysis. From this result, we know that a very limited number of SLA parameters are studied in a state-of-the-art research paper. And let's skip this and this. So to conclude, this paper systematically reviewed the landscape of SLA-based cloud research with a view of answering 4 research questions. And it adopts the systematic review methodology. And their key finding includes the most studied SLA parameters, most commonly used resource allocation techniques, and predominant self-adaptive architecture styles.